topic of this video is derivative rules. Earlier we saw the definition of derivative and how we can use the difference quotient and the limit definition to find the derivative. And that's a much longer way. Now we're going to learn a shorter way and a faster way to find the derivative. So several derivative rules we'll be talking about today. I'm going to make a different video of the proofs of derivative rules. In this video, I'm just showing the derivative rules and how to use them. You should memorize them by heart. They come very, very handy. You shouldn't have to look up to the table and apply the rule. So first one is a constant rule. For any constant c, the derivative is 0. And you can see if you have a graph, a constant function, let's say this is y is equal to 3 or f of x is equal to 3, and that's a constant function, it doesn't change. And this function doesn't have any rise. The rise over run is going to be 0. Slope of tangent line is going to be the 0. Rate of change of this function is 0. So derivative of a constant function is always 0. The second rule is for f of x is equal to x, the derivative is equal to 1. If you have a line y is equal to x or f of x is equal to x, that line has a slope of, you start from 0 because you start from 0 and then we go up 1 over 1. Slope is 1, up 1 over 1. And you do that at every single point on this graph. So slope here is going to be 1. Derivative of y is equal to x is 1. Third rule is the power rule, very, very useful. If we are trying to find the derivative of x to the power n, you are trying to find derivative of any exponent x raised to some exponent, then the power rule says bring the exponent in the front and reduce the exponent by 1. 5x to the fourth is going to be the derivative of x to the 5. So if your function is x to the 5th, the derivative will be 5x to the 4th. If your function is x to the 99, y is equal to x to the 99, then y prime will be 99x to the power 98. Okay. Bring down, to differentiate x to the power n, bring down the exponent as a coefficient and subtract 1 from the exponent. Constant multiple rule. For any constant c of f is differentiable and the derivative of c f prime is equal to c times f prime. So if you're trying to find the derivative of 75x to the third, you can do 75 times derivative of x to the third. Let me rewrite it here. So if your f of x is equal to 75x to the third, f prime of x, you can do 75 times derivative of x to the third, which is 75 times 3x to the second power. And 75 times 3 is equal to 225x to the second power. So you can pull out the constant and then find the derivative and then multiply the constant with the derivative you found. Sum and difference rules. So assume f and g are differentiable, then sum of two functions were differentiable, their sum is also differentiable, and their difference is also differentiable, and you can do the derivative of pieces. For example, 4x to the third plus 7x to the fifth. What's going to be the derivative here? If this is my function f of x, and I want to find out f prime of x, I can do derivative of individual pieces. So I could do the derivative of first piece plus derivative of second piece. We can do a derivative of individual pieces. Your f piece is 4x to the third and g piece is 7x to the fifth. So that gives me 12x squared plus 35x to the fourth. A definition for the number e. The number e is a number such that limit h approaches 0, e to the power h minus 1 over h is equal to 1. So derivative of e to the power x is always e to the power x. Derivative of e to the power x remains e to the power x. So here's the derivative rules we've talked about so far. Memorize them by heart, and now we're going to see use of these rules. F of x is equal to x. What's going to be f prime of x? The notation, if your function is written as f of x, then notation would be f prime of x. If your function is written as y equal to something, then it would be y prime or dy over dx. Derivative of a constant function, we just learned that it's always equal to 1. If you want to use the rule of x to the first power, you can bring 1 and reduce the power of x by 1. So it would be 1 times x to the 0 power, and anything to the 0 power is 1, so the derivative is going to equal 1. Next we have f of x is equal to 1 over x. So f of x is equal to 1 over x. What's the derivative of f of x is equal to 1 over x? For f of x equals 1 over x, we can write it as x to the power negative 1. F prime of x, we can bring the negative 1 in the front, x to the power negative 2, reduce the exponent by 1, so negative 1 times x to the power negative 2. G of w is 5 over 6 w to the 12th power. So g prime of w would be the constant stays in the front, you pull out the exponent, bring the exponent as a coefficient, and reduce the power by 1. So that leaves me with 10w to the 12th power. G prime is equal to 10w to the 11th power, not 12th. Okay, next we have f of s is equal to square root of s over 8. So we can say this is 1 over 8 times square root of s. F of s is 1 over 8, s to the power 1/2. Anytime you're thinking about derivative, it's always good to see the radical as an exponent. It's easier to handle the derivative when you are looking at a radical as an exponent. So f prime of s is going to equal, f prime of s would be equal to 1/8 times 1/2, s to the power 1/2 minus 1, which is 1/2 minus 1 would be negative 1/2. So 1/16 s to the power negative 1/2, or 1 over 16 square root of s. Both are correct. Next, again, we have sum and difference of several functions. When we are finding the derivative, we can do the derivative of individual pieces. So f prime of t would be, think of 6, let's first rewrite it with an exponent. Think of 6 square root of t as 6 to the power 1/2 minus 3 over 7 t to the third minus 101 e to the power t plus e to the power third. So when we do f prime of t, we can do derivative of individual pieces and find the sum and difference of those derivatives. 6t to the power 1/2, 6 times 1/2. When I do 1/2 minus 1, that would be negative 1/2. 3/7 times 3t to the second power minus 101 e to the power t. Derivative is just e to the power t. And e to the third power is a constant, so that derivative of a constant is always 0. So that's going to remain 0. So this turns out to be 3 over square root of t. You can leave it with an exponent, or minus 21 over, 9 over 7, not 21. Minus 9 over 7 t squared minus 101 e to the power t. And that would be my derivative in this case for number 5. For number 6, looks like I have a product of two functions. So how do we find the derivative when we have a product of two functions? Later on, we will learn the derivative of product rule for derivatives, but right now we haven't talked about product rule of derivatives. So I'm just going to go ahead and distribute and then open up the bag. So y comes out to be 5x to the third times x squared would be 5x to the fifth plus 5x to the third plus 3x to the third plus 9x plus x squared plus 3. And that leaves me with 5x to the fifth plus 8x to the third plus x squared plus 9x plus 3. And now we're going to, would be, this is going to be 15 and 18. Yep, 15, not 5. All right, so 5x to the fifth plus 18x to the third plus x squared plus 9x plus 3. Y prime is going to equal 25x to the fourth plus 54x to the second power plus 2x plus 9. Derivative of constant is 0, so that would be not included. Now we're looking at number 7. For number 7, we have something raised to an exponent. Raised to an exponent means I would have to open up that bag, foil it. So h of x, when I foil it, I would be able to write it as if you recall, a plus b squared is a squared plus 2ab plus b squared. So leaves me with x to the 8th plus 16 plus 8x to the 4th. Now h prime of x, this is x to the 8th. H prime of x would be 8x to the 7th plus 32x to the 3rd. And the derivative of 16 is going to be 0. We don't need to write it. Next, we have y is equal to e to the power x times e to the first power plus 1. Can I write it as e times e to the power x plus 1? And e is a constant, so we can pull the constant out, and derivative of e to the power x is just e to the power x. Derivative of 1 is 0. Y prime turns out to be e to the power x, which we can write as e to the power x plus 1, and that's all for this one. Here we have next example. We want to find f prime of x, where f of x is x squared plus x at x equals 3. Earlier we did use the limit definition. We found the derivative by using limit x approaches 3, f of x minus f of 3 over x minus 3, or we did limit h approaches 0, f of 3 plus h minus f of 3 divided by h. So we could use these definitions, but they take a long time. So we're going to use the quick rules we just learned. F of x is x squared plus x, then f prime of x would be 2x plus 1. And now we know the general derivative. We can find it at any value of x. We're looking at x equals 3, so we're going to replace every single x by x equals 3. 2 times 3 plus 1, that is going to be f prime of 3 is going to be 7. Right? Find the equation of the tangent line to the function x equals to the function at x equals a, where a is natural log of 3, f of x is e to the power x. Okay, so to find equation of tangent line, we have talked about first we need the derivative of function, then we use the point slope form to write the equation of line. So we need the slope of tangent line, which is the derivative, which is going to be f prime of x, and then we also need a point on the line. We already know x coordinate of the point on the line. X coordinate is natural log of 3. If I plug natural log of 3 into the y, so f of natural log of 3 would be e to the power natural log of 3, and that simplifies to 3 using the rules of exponents, or rules of exponential functions. So natural log of 3 and 3 is my point. Now, slope of tangent line would be f prime of x, and derivative of e to the power x is just e to the power x. So we want that at the point natural log of 3, so that would be e to the power natural log of 3. And that is going to be 3 again. So write the equation of tangent line. We would use point slope form to write equation of tangent line. We would use point slope form. Y minus y1 equals m x minus x1. Y1 is 3, m is natural log of 3, x1 is, m is not natural log of 3, m is 3. And x1 is natural log of 3. So y minus 3 is equal to 3x minus 3 natural log of 3. And eventually add the 3 to the other side, minus 3 natural log of 3 plus 3. And that's going to be our slope equation of the tangent line. And that is the endpoint equation of tangent line. So this is in the form y is equal to mx plus b, where your m is your slope 3, b is your y-intercept. This entire thing with the negative sign is your y-intercept. Okay, let's see another example. Prove that y is equal to 1 over square root of x is differentiable, and calculate y prime. So assume that x is greater than 0. There's only one point where this can be troublesome, and that point is x equals 0. So 1 over square root of x. So we can prove by doing limit h approaches 0 from the right hand side, f of x plus h minus f of x divided by h. We can use this to prove that the function is differentiable, and to calculate the y prime, we can write y as x to the power negative 1/2, because the same thing as 1 over square root of x, and y prime would be negative 1/2, x to the power negative 1/2 minus 1. Y prime is negative 1/2 x to the power negative 3/2, and that would be the derivative in this case. Few more examples. Find the derivative for part A. 15x to the fourth. For part B, 1/3 x to the power 1/3 minus 1, that's negative 2/3. For part C, negative 1/2 x to the power negative 3/2. For part D, t to the power pi. T is a variable, so it would be pi t to the power pi minus 1. All these are pretty simple. We'll look at one more example. Find the points on graph where the tangent line is horizontal. When is the tangent line horizontal? Tangent line is horizontal whenever the derivative is equal to 0. So at any point where derivative is 0, the tangent line is going to be horizontal. So I'm going to find the derivative and set it equal to 0. F prime of t is 3t squared minus 12. Set f prime of t equal to 0 to find the points where derivative is 0. Find the points where tangent line is horizontal. Tangent line is horizontal means the slope of tangent line is 0. Tangent line is horizontal. So for example, if you have a function like this, it would have a tangent line equal to 0, and the slope of tangent line would be 0 and 0 at these two x values. Let's just say this is, oh no, did not mean to use eraser. I'm going to have to change it now. Let's just say this is x equals 1, x equals 2. At these 2 points, tangent lines are horizontal. Okay. So set the derivative equal to 0, 3t squared minus 12 is 0, t squared minus 4 is 0, t is equal to plus and minus 2. So those are the points where derivative is 0. We want to find exact points. So when t is positive 2, when t is negative 2. If I plug t as positive 2 back in there, 2 to the third power is 8 minus 24 plus 4. And that's going to leave me with negative 12. Negative, if I plug negative 2 in there, that's negative 8 plus 24 plus 8. And that's going to turn out to be positive 20. So these are the points where tangent line, slope of tangent line is 0. Okay, next we have calculate the dg dt at t is equal to 1. Another notation to write dg dt at t is equal to 1 is, you can also write it like this. G prime of t would be, let's just calculate the general derivative, then we can evaluate that derivative at t is equal to 1. Negative 3 t to the power negative 4. Negative 3 t to the power negative 4 plus 2 times 1/2 t to the power 1/2 minus 1 is negative 1/2 plus 4/5 t to the power negative 4/5 minus 1 is negative 9/5. Okay. All right, so g prime of t comes out to be negative 3 t to the power negative 4. And we can cancel these 2's plus t to the power negative 1/2 plus 4 over 5 t to the power negative 9 over 5. Let's see, that looks right. Now we are going to evaluate g prime at 1. So negative 3 times 1 over 1 to the 4th power. I'm just going to use positive exponents. 1 over square root of 1 plus 4/5 times 1 over 1 to the power 9/5. So I'm bringing the exponents down and making them positive, and see what does that come out to be. That's negative 3 plus 1 plus 4/5. And that's going to be negative 2 plus 4/5. That's negative 10, 6 over 5. So 6/5 is, and it's going to be negative 6/5. Yeah, negative 6/5. All right, last example for this section using the basic rules of derivative. Find the equation of tangent line to the graph of this function at x equals 3. We already did several examples. To find equation of tangent line, we need slope of tangent line, which is going to be my derivative at that point, which is f prime of x. And we also need a point on the line. We know the x coordinate is 3. The y coordinate would be 4 e to the power 3 minus 2 times, 2 times 27, which is 54. So that's going to be minus 2 times 3 to the third power. 3 to the third power is 27, which is 54. So point is 3, 4 e to the third minus 54. And this is going to be my x1. This is going to be my y1. Let's find the derivative f prime of x at the point 3. So once we find the general derivative, we're going to find that derivative at point 3, because we want to find equation of tangent line at that particular point. F prime of x would be 4e to the power x minus 6x squared. And f prime of 3 would be 4e to the power 3 minus 6 times 9, 4e to the power 3 minus 54. Yep. So y minus y1 equals mx minus x1. So equation of tangent line. Equation of tangent line would be y minus y1 is equal to mx minus x1, and this is your m, slope of tangent line. y1 is 4e to the power 3 minus 54, so I'm going to put a parentheses. Don't forget to include parentheses, otherwise you might forget to distribute the negative. X minus x1 is 3. Let's simplify. Y minus 4e to the power third plus 54 equals 4e to the power third minus 54. Oh, we have binomials here. I'm going to leave it at this point. You can distribute the binomial if you want to, but I'm just going to leave it in the form y minus y1 equals mx minus x1. That's all for this video.